Hey everyone, let's understand the regression metric called R square. R square is the metric used to evaluate regression models. It is also called coefficient of determination. One way to express R square is it measures how much of variance in the target variable y is explained by the features x. The formula of R square is R square equal to 1 minus sum of residual squares by sum of total mean squares. Here the variables SS res can be seen as the summation of yi minus yi hat whole square, where yi represents the y true and yi hat represents the y prediction variables. Similarly, SS total means the total sum of squares, which is represented by yi minus y mean whole square. This can also be said as the variance in the data. Now, let's understand this with an example. Let's draw a graph in which the x-axis represents some metric of size and the y-axis represents a metric of price. And let's put on red dots which represents the price as per the size. And our regression model predicts prices in a straight line which is represented by this blue line. Let's understand the total sum of squares, which is this yellow line, which basically means that for every house price prediction, we just take a mean of the variables and give the output, which is represented by this yellow line. As an example, let's say the prices are 500 plus 200 and 700. Dividing it by the total number of houses, we have the mean price as 466k. So let's understand the S total in this case. It will be 466 minus true value of 200 whole square plus 466, which is the mean, minus true value of 500 whole square plus 700 minus 466 whole square. Next, let's try to understand the residual sum of squares. The y hat represents the predicted prices and y represents the actual prices. So in this graph, the red dots represent the true values y, and the lines on the blue line, the green dots, represent the predicted values, which is y hat. So let's understand this with an example. SS res will be equal to 380 minus 280 whole square plus, suppose there is a house which has the correct prediction, 220 minus 220 whole square, and so on and so forth. Let's formulate this with a tabular example wherein we have 5 houses which has true values of y of 40, 50, 60, 70, 80 k, and y hat, this is the predicted value, such as 33, 47, 65, 69, 83K. Now the y mean will be the true values divided by the total number of predictions, which in this case comes out to be 60. And let's now calculate the S total, which is summation of yi minus y hat whole square. So the error rate in this case comes out to be 1000. Now let's compute the SS res, which is the residual sum of squares. Which is yi minus y hat whole square. So this comes out to be 48. As you can see, the residual sum of squares is very less than the total sum of squares, which means the prediction model is much better than the average model. Now to quantify this, we need to compute R square. Again, the formula for R square is 1 minus SS res by SS total. Which comes out to be 0.952. So how do we interpret this 0.952? If R square is 1, that means the prediction model was a perfect fit. If R square was 0, that means the model is no better than the average prediction. And if R square is less than 0, that means the model was worse off than the average prediction. And going below 0 is a very exceptional case. So R square, generally when the model tends to be better, it normally lies from the range of 0 to 1. And what does the value 0.952 mean? The interpretation can be the given model explains 95.2% of variance in house prices. And only 4.8% of variation is left unexplained.